Hello and welcome back to another episode of Measurement in a Minute. I'm your host, 𝗬𝗧𝗔𝗬 with Lakeside Process Controls. And in today's video, we're continuing our discussion around rose mount and micromotion flow meter technologies. More specifically, we're talking the basics of fluid mechanics. The last video, we discussed about viscosity, what it is, and the impact of picking an appropriate technology. Today we're going to look at something a little bit similar to this, and it involves both the shear stress and the shear rate. Now, the relationship between both of these will help us identify the type of fluid that we are dealing with. The most common fluid that we deal with are Newtonian fluids, as depicted by this black line. And you can see it's very straightforward. It is a linear relationship, and the fluid begins to flow immediately once force is applied to it. This would be something like water, air, alcohol. Very, very common that you have fluids in your facilities that are Newtonian. The non-Newtonian can be classified slightly differently depending on their behavior. So dilatant fluids are an example of a non-Newtonian fluid, and as you can see, it's identified by this red shaping line that points upwards there. What that tells us is that it'll begin to flow without too much force applied to it, but the harder we apply force to it, the more force we give it, actually the slower it responds. It makes it more difficult to flow. And one thing comes to mind, and that would be cornstarch and water. This is a great example. If you're ever a little kid and you're playing with this cornstarch and water experiment, you can stick your hand in it, no problems. But when you go to hit that liquid mixture, you find that your hand gets stopped at the surface. This is the effect of a dilatant fluid. The opposite to this would be known as a pseudoplastic, where the more force we apply to it, the easier it begins to flow. And as the name implies, this would be things like liquefied plastics, but also things like blood plasma and hair gels. The last one here are known as Bingham fluids, and you can see that's this blue line that's kind of independent between the rest of them, kind of far away from them. And what this is helping us identify is that yes, it is a linear relationship just like Newtonian fluids, but it's going to require a certain amount of force before it begins to start flowing. So you can see the rest of them all start at that XY intercept, that 0, point, but not with Bingham fluids. And examples of this will include toothpaste, paint, chocolate, ketchup, and so forth. And it's very important that we understand the type of fluid that we are dealing with when we're sizing and selecting appropriate flow meter technologies. Should you have any questions about rose mount or micromotion flow meters, please reach out to us at www.lakesidecontrols.com. Thanks and have a great day.